Hello.
Thank you, sir.
Yes, sir.
Yeah. Look here. We have uh, discussion till here, right? Second step, and we were saying that electrons are coming from the ground to neutralize these positive charges, right? So after this neutralization is over, we are doing unearthing, right? Here, a sphere is disconnected from the ground, so this is called unearthing. Okay, is it clear, everyone? Hello.
Yes, sir.
Okay, sphere is disconnected from the ground, and when it is disconnected from the ground, still the positively charged rod is here. After the disconnection is done, at the last step, we are removing the rod from here away. So before removing this rod, positively charged rod, you see the negatively charged are here at one side, right? Isn't it? And when the positively charged rod is removed from here, then the negative charges are uniformly distributed on the surface of the sphere. This one is very important for us to understand that we have these charges uniformly distributed on the surface. If there is no other things are affecting the charges, then the charges will always be uniformly distributed on the sphere. Okay, so here finally the sphere has an induced charge, and the charge is now negative. So what we got here, to make the sphere negatively charged, what we are doing, we are bringing positively charged rod. Now my question is, if we are planning to make the sphere positively charged, then what we have to do? Hello. Hello.
Yes, sir.
Yeah, what we have to do if we eventually want to get positively charged distributed on this sphere uniformly, what we have to do? Can anyone please give your idea what we have to do? Hello. Are you listening, everyone? Lamisa, Adrita, Maimuna, you
Yes,
can
sir.
give me the idea. You understood my question.
Yes, sir.
So can you answer my question? How if someone is saying you that you make the sphere positively charged, then what you have to do? If you think you can explain, then you raise your hand. Anyone, if you think you can explain it, you can raise your hand. Hello. Hello. Yeah. Can anyone explain it? Hello, Labisa, Adrita, Mahi, Monica, Maria, Maimuna. Hello.
Yes, sir.
Can you explain how we'll do that? Or should I repeat the question?
No, sir.
Hmm. Like you are having here this sphere negatively charged, right? Finally, you are getting negatively charged. Now, someone is asking you that how you will get positively charged sphere. What is the way? Then what should be your answer? Yeah, say
Sir, maybe instead of the positively charged rod, we use something negative.
yes, yes. That is the first thing. Then what will happen if you are bringing negatively charged rod here? Then what will happen? Left side will be
Positive,
le- positive and right side will be
negative.
negative. Then if you are doing earthing, what will happen? Here we are getting electrons move from the ground to the sphere, right? So that time what
Yes,
will
sir.
happen? Electrons
Move
will
from the sphere to the ground.
yes, electrons will move from the sphere to the ground. Is it clear?
Yes, sir.
Then what will happen? Same like this one. Sphere is disconnected from ground, so here only positive charge left, right?
Yes, sir.
Then you are removing the rod away, then it will be uniformly distributed positively charged. That's it.
Okay, sir.
Is it clear?
Yes, sir.
Yeah. So what about others? You understood? Adrita, Mahi,
Yes, sir.
then Monica, you understood? Mariam,
Yes, sir.
Lamisa,
Yes, sir. Yes, sir.
yeah. So this way we have to actually apply our learnings. Okay. Whatever we are learning, we have to apply that one. So did you take the notes of it?
Yes, sir.
Everything you wrote?
Yes, sir.
All of you? Lamisa already wrote. Then Adrita wrote. Adrita,
Yes,
Monica,
sir.
Monica, have you taken notes?
Yes, sir.
Okay, mashallah, you all are very fast. But I expected the response also that you you all are answering promptly. So here we have some. We can go back to see the learning outcomes, and we can have an overview so that we can understand how much we are done from the topic and how much is left. Yeah. So we are done with how many learning outcomes here? A is done, right? Describe experiments to show electrostatic charging by friction. A is done, right?
Yes. Yes, sir.
Then B, explain that charging of solids involve a movement of electrons. That one we also showed you, that loss of electrons and gain of electrons, right?
Yes, sir.
Yes, sir.
Okay, then G, describe the separation of charges by induction. That one is done, right?
Yes, sir.
Hmm. Now we will go for this C, D, then E, F together. Huh? And we also got this one, that state what is meant by earthing a charged object. This one is also done, right?
Yes, sir.
Yes, sir.
What is called earthing, Mahe? To connect the
Sir, earthing refers to contact with the Earth's surface
yeah, yeah,
electrons.
yeah, yeah. Earthing means to connect the object, charge object with the ground, right? With a conductor, by using a
Yes, sir.
conductor, right?
Yes,
Like
sir.
Yes,
any
sir.
metal objects, we can connect with the ground and the charge object, that is called earthing. Mainly we are using copper, but any metal will work over there. Okay, so here we have we have some properties of charge and unit of charge. Please write this, huh? All of you please write this. So this date is for another class, so you ignore this, other things you write. Okay, so can you read it, Monica, from here, what is written here?
Nature, property of charge, and unit of charge. If an positive, no, if an object loses electron, it becomes positively charged. If an object gains electron, it becomes negatively charged. Unlike charges attract and like charges repel, the charge of an object is measured in coulombs. See.
Okay, that means the unit of charge is coulomb. So this idea already you have, that is positively charged, negatively charged ones, and also you understand from magnetism that in magnetism you got unlike charges, unlike poles attract. Now you have unlike charges attract, like poles repel. So here we got like charges repel. Similar idea, right? These are not that tough thing, very simple thing. Okay, then next, are you done with writing, everyone?
No, sir.
Only this information is new for you. That is, the charge of an object is measured in coulombs. The other things you know. So can we go to the next? Hello.
Yes, sir.
Okay, now after this we have electric field. Like the magnetic field one, we have also electric field. Similar idea. Yeah, Lamisa, read here. Lamisa. Hello, Lamisa. Lamisa,
Yes, sir.
can you please read electric field?
Yes, sir. Electric field, it is a region where a charged particles experiences a force. Electric field lines come out from a positive charge and they get into towards a negative charge.
Okay. Electric field lines come out from a positive charge and that they get into towards a negative charge. In magnetic field lines, we got north pole to south pole, the field lines direction. Here for electric charge, we have positive and negative. Positive, for positive charges, the field lines are coming outwards, and for negative, the field lines are going inwards. We are showing you the diagram. You please write this, then we are going to show you the diagram. Are you done with writing, everyone? Hello?
Yes, sir, done.
Okay. Hmm. Yeah, here you go. Positive charge come outwards, the field lines. Negative charges, the field lines are going inwards. Draw this diagram, huh, everyone? Are you done with drawing?
Yes,
Yes,
sir.
sir.
Okay, now if two if two charges, one is positive, another one is negative, they are brought closer to each other, how the field lines will work is shown here. You see the red colored one, that one is positively charged. The blue color one negatively charged. The field lines are going from positive to negative. Okay, is it clear?
Yes, sir.
Done, sir.
Yeah, done.
Yes, sir.
Now you are getting another exclusive thing, that is here we have two parallel plates. Other than having point charges, we are having two parallel plates, and the field lines, you see, they are going from the parallel plates positive to negative like before they are going, and they are going straight till here, and at the end they are going little bit curved, and at the indest one, you see, at the corner one is going a bit more curved, right? Is it? Is it clear? Hello?
Yes, sir.
So here, why is behaving like this? We have the explanation here. You please read here, Maimuna.
The electric field lines between two parallel plates are straight and parallel to each other in the middle. However, they become curved at the end corner as field lines get weaker at the end.
So you understood why they are becoming curved at the end. What is the reason?
Yes, sir.
What is the reason?
Because they get weaker.
Weaker. So you write the heading here, the field lines between two parallel plates. Okay. Then you draw this diagram. After finishing this diagram, we will write that writing. Done? Drawing is done, everyone. You be very much, careful during drawing the lines and their direction. Okay, the direction of the lines always, it will be, for positive it will be outwards, and for negative it will be inwards.
Done, sir.
Okay, write this note, please.
Done, sir.
You have idea about thermal conductors and thermal insulators, right? Similar to that, we have electrical conductors and electrical insulators. So here we have the definition. You write please the heading electrical conductors, and here we have electrical insulators. Mahi, can you please read it? Electrical conductors.
Okay, sir. Electrical conductors, the material which allow electricity flow of electrons to pass through them easily are called electrical conductors. Metals are very good conductors because they have free electrons in their structure. Electrical insulators, materials which do not allow electricity to pass through them are called electrical insulators. Examples: plastic, wood, clothes, etc. are electrical insulators.
Okay, so please write these definitions. Electrical conductors and insulators. Done.
Yes, sir.
Yesterday in Dhaka we had thunderstorm, right? Hello,
Yes, sir.
and we get this thunderstorm before the rain or during the rain, right?
Yes, sir.
And the reason for this thunderstorm is uh, the collision or the friction or rubbing with the water molecules in the clouds, right? Or the air particles. Air molecules, they have friction with the cloud or water molecules. So due to this friction, there is uh, transfer of electrons, right? And there the electrons are deposited. Here you see the cloud when when they are getting any conductors close to them, these charges, then they try to travel to that path, through that path. Like we have any tree here or plant here, or any water body, that type of conductors, then these electrons are getting a path to travel. Then there is huge amount of electrons travel through this section within very small time. Then we have flash of light, with sparking flash of light, and sound is also coming. You can understand when we are only doing a small ironing, that time we are getting the sound. But when there is cloud, huge amount of electrons are there, millions zillions of electrons are there, they are traveling within a fraction of seconds. That time the sound is huge, right? Isn't it? And the sparking is also huge. That's why we are getting flash of light and sound during the thunderstorm. Is it clear? This part you will not write today. Today I'm just showing you, and next class you will write, and I will have more explanation on this. Here I have some explanation. In next class we will repeat it, no problem. Yeah, Adrita, can you read it?
Yes, sir. Lightning and static electricity. Due to friction with cloud and cloud or cloud and air, cloud gets charged. When the lower part of the cloud gets negatively charged due to induction electrons from the upper part of conductor, plants, trees, animals, humans, water reservoir, metal structures, etc., move away by repelling. As a result, the upper side of the conductor becomes positively charged. When the cloud's negative side is very close, the induced conductor, huge amount of electrons get their path to flow through it within short time, which creates sparking of fire and sound that we call lightning or thunder.
Okay, I'm going to the diagram again. Now you'll understand after having the discussion and writing here. You will understand now it better. Look, at the beginning, as we got the idea before, that at the beginning everything is neutral. Here, the plants, animals, or anything we are getting here, those are neutral. But when they comes closer to this cloud, or these clouds come closer to this plant, in other words we can say, and what happens, these electrons, they are repelling the electrons available in the plants, right? So what happens, this part becomes positively charged, right? Isn't it? And uh, these plants, they are already connected to the ground. That's why the negative charges here in the plants, they are moving away. The negative charges already they had, that one we are talking about. That means everything is neutral at the beginning, right? Isn't it? Hello? Hello, are you understanding?
Yes, sir.
So the charge due to induction already you got that notes, you focus. When we are bringing any charged particle closer to a neutral object, that time what happens? The charged particles charge, it is negative here, so it will repel the negative charges on the uh, uncharged one. Okay, so negative will go to the ground, and here only we have positive. So this positive will now attract these negative ones, and due to this attraction, these electrons will flow towards these plants. Is it clear now? Hello? Hello?
Yes, sir.
Okay, so due to this, we are getting here, uh, flow of electrons from the cloud to the plant. Within fraction of second, lots of electrons are going. and due to their flow we are getting, or due to their transfer we are getting the lightning and also the sound. Okay, clear to everyone? In next class
Yes, sir.
we will write it and we will have this diagram inshallah. Okay, Allah Hafiz. Thank you so much everyone.